Yo, this is Coach Ray, recording another video. Today's on adding and subtracting rationals. Just a quick refresher. Rationals are just fractions, and in this unit, rationals are fractions with polynomials in them. So we've got all kinds of polynomials, quadratic, binomials, monomials, everything makes up our fractions. The first lesson we did was on multiplying and dividing, and then now we're doing adding and subtracting, and adding and subtracting is harder than multiplying and dividing. Okay, so before we get into adding, subtracting rationals, let's do a quick review on adding, subtracting just fractions. Okay, we will do 2/3 plus 4/5. What's the rule to adding fractions? Same denominator. We need the same denominator. Okay, so what I could do is I could multiply this 3 by a 5 and multiply that 5 by a 3. And that will create a denominator of 15 on both sides. Beautiful. Okay, now you can do almost anything you want in algebra as long as you do something to keep yourself from breaking the law. Okay, so the one thing I need to do to keep from breaking the law is go like this. So now I'm multiplying 2/3 by 1. 5/5 is 1. All right, so I'm allowed to multiply by 1 because it doesn't change anything. It'll look different, but technically I'm not changing anything. And same thing over here. All right, so now what do I got? I got 10 over 15. Plus 12 over 15. All right, what happens with my denominators now? Stay the same. Okay, so I'm going to just keep this 15. Then I'm going to do a little work up here. 10 plus 12 is 22. There we go. Any questions on that?
That's not part of the example, right?
No.
Okay,
No, that is not one of our examples. I'm going to leave this here, though, while we do example 1, so you can see how it's pretty much the same thing. All right. Thank you.
Do you have them?
I don't know. I don't see a name. Oh, Kendall Spellman and Z. Yeah, I got them. Kendall and Z, you got a thing. Grab it later. All right. Sorry for the interruption. Let's go to example 1. Any guesses on what the first step is in example 1? Factor. Maybe that's what you meant, but factor for sure. Okay. So. Bottom left, this factors to be x plus 2, x minus 1. 3x on top is not factored, so we're leaving that a monomial. Please no mumbling. Okay, this one, bottom right, factors to be x minus 3 and x minus 1. Okay, and on top we got a 2. So far, so good. Factored in both. All right, now we're going to kind of compare this to what we did over here. Now we can see our denominators clearly, and I need them to be the same. So it's pretty obvious that the denominator on the left is not the same as the denominator on the right. So I need to use multiplication to make them the same. Notice back in our example over here, I was not able to be like, oh, I could just do 3 plus 2 to make my denominator 5. That's not okay. All right, you have to use multiplication. But no problem. All right, so watch closely as to how I'm going to make these denominators the same. I'm looking at the left one, I see x plus 2 and x minus 1. Look at the right one, I see x minus 3. I see x minus 1, so at least the x minus 1 is the same, correct? I think I'll be a little bit closer to these being the same if I add an x plus 2 down over here. And sorry, I said add, but I'm really multiplying it times those other ones. Okay, so I'm a little bit closer. And now if I look back at the left one, now I've got my x minus 1 and my x plus 2 the same on both, and all the one on the left needs is that x minus 3. My denominators are the same now?
Yeah.
Okay, I got to avoid breaking the law. So if I multiply the bottom by x plus 2, if I multiply the top by x plus 2 also, now it's just like I'm multiplying by 1. Okay, same thing over here. If I multiply by x minus 3, I'm going to multiply the top by x minus 3. Okay, next line. I'm going to draw a big old denominator. Because I got a whole bunch of crap down here. I got x minus 3. I got x plus 2. I got x minus 1. Alright, and that's like this step over here where I had my 15. My 15 is my denominator. And then my denominator just stayed 15. So I just wrote that because I know it's going to stay the same. Alright, got to do a little bit of work for the numerator though. I need to add all of this plus all of this. All right, adding polynomials is just combining like terms, but you cannot combine like terms until you distribute. When you distribute, then you can see what your like terms are, and then you can combine them. So it's going to look like this. 3x times x is 3x squared. 3x times negative 3 is negative 9x. Over here, 2 times x is positive 2x. 2 times 2 is positive 4. Now I'm going to combine my two like terms in the middle. Okay, so I've got 3x squared did not have a like term, but these middle two become negative 7x, and then I got plus 4, and on the bottom I still have this whole x minus 3, x plus 2, x minus 1, and I'm done. That's it. Questions? Okay, give people a second to copy that down. Yes, ma'am.
Okay, so like, you know how on the bottom, let's say that it's the same thing, so like x minus 1, and then there's another x minus 1, will we also cancel that?
If they're both in the bottom?
Yeah.
No. You only cancel if there's one on the top and one on the bottom that are exactly the same. Let me show you something super weird that I've had students do every year. I never in a million years thought I would have to even tell this to a class, but this is really weird and it happens every year. Some students, and I'm looking at this red line, they put their x minus 3 in on the left, they put their x plus 2 in on the right, they understand that, then they go, okay, if I got x plus 2 on the bottom, I need an x plus 2 on the top, and then they cancel their x plus 2 and their x plus 2. I'm like, what? No, we needed that there. The whole purpose for us doing things is to put that there. So even though, yes, there is an x plus 2 on the top and bottom, we need that there to make our denominators the same. All right, example 2 is significantly more difficult. All right. Step 1, I'm going to factor everything. I got x plus 4 on top here. What kind of factoring is x squared minus 16? Difference of perfect squares. Very nice. So that becomes x plus 4 and x minus 4. Okay, then I got minus. Got x minus 5 on top over here. And I've got x minus 4 times x plus 1. Everything's factored. Are my denominators the same? No, obviously not. Let's make them the same. Let's see, I got an x plus 4 and x minus 4 here. I already have an x minus 4 here. It needs an x plus 4 on the right. So that means all this one needs is an x plus 1. All right, so I like to go immediately write what my whole new denominator is going to be. X plus 1, x plus 4, and x minus 4. Okay, to avoid breaking the law, I got to multiply by the same thing on top. So I'm going to need to multiply by an x plus 1 up here. I'm going to need to multiply by an x plus 4 up here. All right, and in example 1, I just distributed. And I'm going to distribute again, but it's a little bit different. When you're distributing with a binomial and a binomial, we got a 4-letter F word that we use for that. FOIL. Okay, so FOIL. First, outside, inside, last. So I got x squared, let's see, plus 5x plus 4. Okay, over here I've got x squared minus x minus 20. All right, and I'm pausing right here because right here on every subtraction problem, this is where everybody messes up. So major key, I want to slow down my voice and emphasize and make sure you're really paying close attention. This is a minus problem, yes?
Yes.
So I've got to do this x squared plus 5x plus 4, this quadratic, minus this quadratic, x squared minus x minus 20. Okay? What everybody's going to do is they're just going to put a minus sign in the middle and they're going to start subtracting, and that will be wrong. Because now all you're subtracting is this first x squared. You're not subtracting the entire polynomial. I need to go like this for the back one so that I'm subtracting the entire polynomial. I can put the front one in parentheses too, but there's just nothing that's going to distribute in there. All right, so I believe that the most common mistake in all of algebra is forgetting to distribute a negative in a situation just like this. Okay, so if you put it in parentheses, you recognize that you got -1 here and you got to distribute it to everything. So now I'm going to have x squared plus 5x plus 4. That didn't change. But now I have negative x squared. Now I have positive x. Now I got positive 20 over all that crap. And I'll write it in my answer, but I don't want to keep writing the same denominator over and over. Okay. Next, let's combine like terms. Let's see, x squared minus x squared, gone, right? That equals 0. 5x plus 1x, 6x. Okay, 4, positive 20, positive 24. I feel done, but I'm not. And this doesn't always happen, but in this particular problem it happens. Does anybody see the one more thing we can do to simplify? We can factor the top a little bit, okay, using greatest common factor. And do you see why in this problem it was really important to do that? So we can cancel that x plus 4. Okay? If we factored the top and it didn't cancel with anything, then I would have said you shouldn't have even factored the top. You didn't need to do all that. But in this particular problem, it creates something that cancels. So our final answer is 6 over x plus 1 times x minus 4. Okay, and I know you're going to need to finish copying that down, and I'll scroll back down in a second so that you can. But I want you to see something up at the beginning of the problem. Watch this. Eyes up front. In red right here. Okay? When I factored, I've done this same problem year after year after year, and I just move on past something unless the student in the class points it out, but no one ever has. Right here, I had x plus 4 on top, x plus 4 on the bottom. I could have, boom, boom, canceled those two and just had 1 over x minus 4. That would have made this problem a lot simpler, because then if you just had an x minus 4 on the bottom on the left, all you would need is an x plus 1 with it to make them the same denominator, and the problem gets a lot easier. I like showing the entire problem so that you can see what you have to do if that scenario doesn't happen, but just a heads up, you could have canceled in the beginning, or you can cancel it at the end either way. All right, and that's it for these notes. Be on the lookout for another set of notes coming up. Thank you for being with us. We'll see you next time. Deuces.